Hello, my peeps. Today's podcast for Algebra Nation is going to be workbook pages 19 through 22. So please grab your workbook, turn to page 19. Here we go.
Here we're going to be talking about domain and range. And domain and range deal with what's called a relation. A relation is a relationship between two variables. For example, a chart with two columns, a point with two coordinates, y, an equation with two variables. The idea is with domain and range, domain is going to be all the possible x coordinates, and range is going to be all the possible y coordinates. So what's going to happen overall is we're going to start to write sets of domain and range. So consider the following relation. We have x and y coordinates. We want to find the domain, and then we want to find what's the range. If you notice, before I even get to this, I've got a little study edge tip for you guys. When you write a set, only list each number one time and list it in order. Got it? Write it one time and in order, smallest to largest. Considering this relation, find the domain, and we'll find the range. Find the domain. Remember, a coordinate is x comma y, meaning I'm going to look at all the x coordinates, 2, 3, 1, and 4. I'm going to write it in order, meaning the smallest is 1, then 2, then 3, 8, then 4. And remember our set notation. So all of these elements are the set for the domain. Then the range is all the y's. In this case, we would have 3, 7, 2, and 3. 3, 7, 2, and 3. The smallest is 2. 3 appeared twice, but you only put it one time. And then lastly, 7. We put it in set notation. So here's an example of given some points. How do you write the set for domain and the set for range? Next up, let's talk about a line segment. So looking at this line segment, we're going to look at the end points of a line segment. For domain, remember, domain is x's, and we have our x-axis and our y-axis. To find the domain in this case, we look at the point furthest or farthest to the left. If we go to the left, I see that that point is negative 2. We take the point farthest to the right. The point furthest to the right is going to end up being positive 2 in this case. See it? It's positive 2. So basically, you're going to look to the left, then you're going to look to the right, and when you write it in the following form. The smallest number is negative 2, the largest number is 2, and x is between these two numbers. And make sure you write the inequality correctly. The way you read this is x is between negative 2 and 2. Or more specifically, x is greater than or equal to negative 2. X is less than or equal to positive 2, meaning it's in between. So for domain, you look left and right. For range, you look down and then up. Look for the point furthest down. The y coordinate furthest down is going to end up being 1, and the one furthest up is going to be 3. So furthest down would be 1, furthest up would be 3. You want to write this again, 1 and 3, bottom number, top number, the smallest, the largest, the lowest, the highest. And y would be in between these two numbers. So there you go for a line segment. I want you guys to go ahead and try this one. Pause the video. Find me the domain, find me the range. So we look furthest to the left. Don't worry about up and down. Domain is again left to right. We go furthest to the left. The leftmost number for x is negative 2. The rightmost x is positive 2, and it's everything in between. For range, the lowest y is negative 1. The highest y is 3. Because remember, our coordinate, once again, is x comma y, and y would be between these two numbers. You've got your domain and your range. I want you to try one more here on the very bottom. Pause the video one more time, okay? And give this one a try. Just a little different. Okay. Now here we have what's called a continuous piecewise line segment. A lot of words, right? Basically, it's just a broken up little piece of line all connected together. It still follows the same idea. What is the leftmost x? And the leftmost x is going to be 1. The
But before we have the parabola, let's take a brain break. It might be painful for you, depending on who your favorite basketball team is. I hope that guy likes cake. That's gotta hurt. Okay, back to work.
A parabola, of course, you're going to see is going to have what's called a turning point. It turns around. So for parabolas, you can either open up or open downward. So that's one type, and the other types open left and open right. For the ones that open up and downward, you're going to see that as they open upward, the domain is actually going to be all reals, is the idea. But the range goes from lowest point all the way up, forever. And that's if it's opening upward. However, if it opens downward, you'll see the domain goes left to right forever is still all reals. See that vertex is that highest point. So the range is everything below that point is the idea. So with that in mind, looking at these problems open up or down, the domain is all reals, the range starts at that point called the vertex. So in this case, looking at these two examples, no need to try it, we'll do this one together. The domains would be all numbers. Range starts at the vertex. Starting at the vertex here is 1. If you notice everything above, everything greater, so you'd write this as y is greater than or equal to 1. Y is greater than or equal to 1. But for this one, it's everything below, which would be less than or equal to. Here the vertex starts at the y coordinate of 2, so the range in this case would be y is less than or equal to 2. So if you have a parabola opening up or opening down, the domain is all the numbers because it goes left and right forever, but the range starts at the vertex. And then these parabolas down here open left and right. So now everything gets switched. The range is all numbers. It goes up and down forever. It goes up and down forever. The domain starts at the vertex. So again, looking at these two examples, you'll see the range is all numbers. Now let's look at domain. Here we have the vertex. The x-coordinate is -1. Is everything greater than or equal to? And we would put x is greater than or equal to -1. For this graph, again, it starts at the vertex 2. Is everything less than? Remember, for x's, less is to the left. Now I would have x is less than or equal to +2. So now that you've seen all these different combinations, it's about that time. The set of ordered pairs shows below a relation. X's and y's. What is the value of the smallest element in the range? We want the smallest element in the range. Remember, range is all your possible y's. So I'm going to look at actually all the y coordinates here. And I just want the smallest. And if you notice, looking at just the y's, I've got, let's see, 1, 3, 2, 5, 2, -3, and 2. -3 would be the smallest. And that's your answer, -3. So instead of asking for just all domain and all range, they wanted a specific number, specific point in the range, the smallest. And then let's do another continuous piecewise line segment. I made a graph of how awesome you are over the last several months. As you can see, your awesomeness is awesome. Regardless, you have...
No, that's not a graph of the awesomeness of the Miami Heat. Get real. Focus.
Have a line segment. Based on the graph, which of the following best describes the range of your awesomeness? Range, remember, is y's. Range is y, so automatically A and B are out because A and B are x's. So is it 10 to 65 or 0 to 40? So let's look at it again. The y. The lowest y is 10. The highest y is 65, and that is your range. Y is between 10 and 65. So overall, with relationships, make sure you can find domain and range for given points, a line segment, a continuous piecewise line segment, or a parabola.
Don't forget to show your workbook to your crazy math teacher.